Good morning students. This is operator chapter continues and this is bitwise operator. We had left this bitwise operator. We are continuing with this bitwise operator. So bitwise operator, what are bitwise operator? Bitwise operator always works on bits level. Bit means 0 and 1. These are called bits. In binary digit, actually bits is the short form of binary digit. Binary digit we have only two, 0 and 1. This 0 indicates false and this 1 indicates true. Okay. Now we'll talk about a table which represents these 0 and 1. A table which represents these 0 and 1. These 0 and 1 will be input and based on that what will be the output. This complete table is called binary table or truth table. Truth table is the representation of binary input in the form of 0 or 1 or true or false, and based on operation it will produce one output. Let's see how. It will produce result based on how many inputs you are giving and how many outputs it is giving. Here you will have only one output based on input. Maybe you are giving 2 input or 3 input or 4 input, it will have only one output. Okay. Now let's see how we will draw one truth table. How we will draw one truth table. Truth table is simple a combination of truth values. Input and based on that output values. And what will be the input and output? Input and output will be always 0 or 1, 0 and 1 maybe, and output will be either 0 or 1. Let's see how. First of all, we will see we are talking about 2 input. 2 input means 2 to the power 2. Means 2 to the power 2 means 4. It means maximum we will have 4 digits. Maximum we will have 4 separate digits or 4 separate combinations, I should say 4 separate combinations. What are the combinations? Let me divide it by 2 because we have 2 digits, one is 0 and one is 1, so both will have half part. So by 2 means 2, it means 2 zeros we have and 2 1 we have. So we will start with 0. So here 2 0 and then 2 1. Done. Just this will have half. It means 2 zeros, so 1 0, 1 1. Same it will repeat 1 0, 1 1. How many are there? Continuously up to that it will fill. Okay. Now let's see bitwise AND. You might have learned logical AND. In logical AND we had 2 AND symbols. Okay. In bitwise AND only one AND symbol. Bitwise or only one OR symbol. In logical AND we had 2. Okay. So remember this. These 1 indicates these will work on bit level. We will see one example how it is working on bit level. Okay. So this is bitwise AND, this is bitwise OR, and this is bitwise XOR symbol. So bitwise AND, let's talk about bitwise AND. Do you remember logical AND? In logical AND how table will work? How table was working? Very simple. It was working if both the inputs are AND. Rather 1. If both the inputs are 1, then it was producing 1. So here also same. If both the inputs are 1, then it will produce 1. Otherwise 0. So 0, 0, 0. It means if first input is 0, second input is 0, it will produce 0 if A and B is asked. Bitwise AND. First input is 0, second input is 1. And if bitwise A and B is asked, then it will produce 0. If first input is 1, second input is 0, and if A bitwise and B is asked, it will produce 0. But if first input is 1, second input also 1, then it will produce 1 if A, bitwise and B is asked. But in case of bitwise OR says if anyone is true. If anyone is true, either first one is true or second one is true or both are true, then it will produce 1. I repeat, bitwise OR says if any of the input is true, that is 1, then it will produce result as 1. So let's see, both are 0, so it will produce 0. This is 1, so it will produce 1. This is 1, so it will produce 1. Both are 1, so it will produce 1. Students, when you will check this, you will completely ignore this. Okay, actually this is one table. Ignoring this is one table. Ignoring these two, this is one table. I have combined here. I think you are in standard 9 or 10. You might be understanding this. In one table I am showing this. Okay. So bitwise OR is over. Now next one is bitwise XOR. This is new for you. Its rule is we will count 1. We will count inputs which are 1. We will count input which are 1. If those ones are even in number. Even in number means either 2 or 4 or 6 or 8, like that. In that case it will produce 0. But if both are 0 means or all inputs are 0, then we consider this as 0. If all inputs are 0, we will consider it as 0. And if number of inputs as 1 are even, means number of ones are even, then it will produce 0. See, so both are 0. As I told you, if both are 0 means all are 0, then 0. So these two you ignore. So both are 0, so it is producing 0. Now here you count how many ones are there. This is 0, this is 1. How many 1? Only 1. So it will produce 1. Here how many 1? Only 1. So it will produce 1. How many 1? 1, 2. 2 ones are there. 2 is a even number or what? Even number. It means it will produce now these are only 2 inputs, maybe more inputs. It will produce, it will follow the same process. If 4 inputs are there, okay, in that case 2 more input will be there, and in those 2 more input, suppose 1, 1, 1, 1 will be there. In that case 4 ones will be there. So 4 is a even number, then it will produce 0. Okay, is it clear? Okay, let's see one example. How questions are asked from here. If, let's see from book. Take from book. A equal to 12, B equal to 10. Let's see. And then we are supposed to find A and B. What will be the answer? Let me tell you how. A represents 12, B represents 10. So binary, since what? This is what? Bitwise operator. So it should work on bit level. Bit level means we are supposed to convert this into binary form. So what will be right? Binary equivalent of this. Binary equivalent of 12 will be what? How will you convert binary equivalent? Let me tell you. 12. divide by 2. 2 6 are 12, remainder you write here 0. 2 3 are 6, remainder 0. 2 1 are 2, remainder 1. From here down to top you take. What will be? 1 1 0 0. So it will be what? 1 1 0 0. 1 1 0 0. Similarly, another one, binary equivalent of this 10. When you will convert, it will be this one. How you want to see? Let's see. 10. Divide by 2. 2 5s are 10. Remainder 0. 2 2s are 4. Remainder 1. 2 1s are 2. Remainder 0. So 1 0 1 0 1 0 1 0. Okay. Now let's see. A and B we will convert, right? So for A and B I am writing here itself I am doing A and B. A and B, what will be A and B? And just go to that table. A, B, A and B. This table 0 0 1 1 0 1 0 1. Go to this table. This AND says if both are 1 then 1, otherwise 0. So this rule will follow here. So let's see 0 0 0 0 0. So it will give 0. Now 0 1 0 1 it is giving 0 0. 1 0 1 0 it is giving 0 0. 1 1 it is giving 1. So 1. So what will be the binary form of A and B? 1 0 0 0. Right? Now reconvert it into decimal because these are in decimal. So answer is expected in decimal. So how to convert that in decimal? I am drawing it. Okay. Same you write 1 0 0 0. Just you write 2 to the power. You might be studied in 6 7 8. Okay. So again I am giving you 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 0 means 1. This is 2. 2 to the power 2 means 4. 2 to the power 3 means 8. Now multiply this and this. 1 into 0. 1 into 0, 0. 2 into 0, 0. 4 into 0, 0. 8 into 1, 8. Now add. What will be the answer? 8. So what can I write? A and B will be equal to A. This is the answer. Okay.